Matrix dimensions. So you have a matrix, and the way you determine its dimensions is you go by the rows across and the columns up and down, which makes a lot of sense because, you know, a building has columns which holds it up and down. So that's why columns are up and down, and we sit in rows in our chairs. That's how I remember it. So it goes rows by columns. So this one is going to be, here's the rows, 2 by 2. This one is a 2 by 2 matrix, and we call it also a square matrix. Anytime the number of rows equals the number of columns, it's called a square matrix. So I usually draw across. Rows is 2 by 1, 2, 3. That's a 2 by 3. Rows 1, 2, 3 by 2. That's how you determine the dimensions of a matrix. Okay, this one is 2 by 1. This one is 1 by 2. They look really similar, but they're the switch of each other. And so the rows and the columns are the reverse of the columns and rows. Rows is 3 by 1. Rows is 1 by 1, 2, 3. This one, 1, 2, 3 is the rows by 1, 2, 3. That's another square matrix. Number of rows here is 1 by the number of columns, 1, 2, 3, 4, 5, 6. That's a 1 by 6. And this one is 1 by 1. A square matrix, but we also have a special name for that. We could call it a scalar. Sometimes I want to multiply a matrix by a scalar. So a scalar can look just like a number on the outside. It doesn't have to be in the matrix brackets. So just like distributing with parentheses in algebra, I have to multiply this 4 to every cell inside this matrix. So first I'm going to do this. And sometimes I even will go like this so I can keep track of how much I'm doing. 4 times 11, 44. That's the first one. 4 times 2, 8. 4 times 0, 0. 4 times 10, 40. All done. So I'm going to do this again, and I'm going to write this out, and I'm going to have 3 in each column. 3 times 7, 21. 3 times x, 3x. 3 times 2, 6. 3 times y, 3y. 3 times 1, 3. 3 times 5, 15. And then finally, this one, see if I have room to write this out. And I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I usually do this kind of thing. So if I have multiple things to do, I don't miss something, then waste my time going back, having to check my work. Z is going to multiply to every cell. I have 4z. I have 3z, didn't leave a lot of room. I have negative 1z. I have 10z, that one goes here. I have xz, and I have rz. And I do cross my z's because sometimes the z looks like a 2 to me, so that's why I cross it. Each cell in a matrix has a name, and its name is its row by its column. So I'm going to call this row 1, column 1, row 1, column 2, row 1, column 3. This will be row 2, column 1, row 2, column 2, row 2, column 3. And this one is, it's a 1 by 2. So I'm going to have row 1, column 1, row 1, column 2. This will be handy in the future. Thanks for being here.